Well, hi everybody. This is Crown. Just wanted to show you guys what I've been working on. Uh, what I've got here. Just briefly go through what I've done. I've got about a 7 3/4 inch rotor here. I've got 1 inch Neo magnets. I believe they're 1 inch by 3/4. I believe they're N52s or N48s. I believe they're N52s. Pretty strong magnets. I've got 3 coils on here right now. I'm using this coil and this coil over here as my run coils. I've got an identical coil here that I'm using excuse me, as my charge coil. And each coil, I'll bring around here so you can see, but each coil has actually 5 turns on it. And I don't know if I can zoom in and where you can actually see that, but each coil has 5 turns, or 5 separate wires, 5 strands. Each of the 5 are 150 foot long. 4 of them are 22 gauge and 1 of them is a 24 gauge, and I use a 24 gauge for my trigger coil, and the 4 strands of the 22 gauge I'm using for my run coil. And talking with a few guys on the forum, I probably should have went with 18 gauge, but I just bought the big spool of like 11 pounds of the 22 gauge, so I went ahead and used that. But excuse me, basically what I've got here, I've got the all of my start, and these are by the way, these are all 5 are twisted, so I ran 5 strands, twisted them with the drill, and then wound that onto a spool loosely, and then from that I wound it onto each coil. This is my start, all 5 starts, and coming out here are my end, all 5 of the ends of my strands. They all come up and go into this board right here, this connector board, and then from that I come over to this circuit. I'll show you the circuit here, and nothing really fancy about this circuit. It's a Bedini trigger coil circuit. It's been it's a Tin Man's modification of the Bedini circuit, which is a single battery. And after that, I've actually added a total of 4 transistors into that circuit. So I've got a common potentiometer, a common trigger coil connection that kind of controls the 4 separate circuits with the transistors. This complete circuit board controls only this coil with all 5 strands, 1 being the trigger and 4 being the run. And then over here I've got yet another same thing basically. Over here I've got another 5 strand coil. Again, all the strands were twisted before they were together, before they were put onto the spool for the coil. And here is the other circuit board. This circuit board is basically the same thing as the other circuit board, with the exception that I can expand this up to 8. I'm only using 4 transistors right here. I can expand this up to 8 if I so choose. I was going to go that route first, and then I decided, instead of running all the wires around, making it permanent, because I have to end up changing my plan quite often, because it just doesn't sometimes work the way I want, so I change it up. So I wanted something that was somewhat convertible, that I could portable, that I could move around from plan to plan without completely destroying it. And my third coil that I've got here is identical to the other 2 coils. Again, 5 strands twisted. I'm using 4 of the strands, which are the 22 gauge. Not sure how well you can see that, but I've got 4 22 gauge and 1 24 gauge, and I'm not using the 24 gauge at this time. I'm using just the 4 22 gauge strands, and I'm running those through each one separately through a full wave bridge rectifier. And from that, and by the way, if you see something that I'm doing wrong here, please don't hesitate to leave me a message on the forum under Pulse Motors. And anyway, what I've done, I'm not sure that this is good or bad or whatever, but I've taken, we've got a positive and a negative coming out of each rectifier, or bridge rectifier, obviously, and I've connected all the positives together, and then I've ran it over to a 25 volt capacitor, and then I've taken all the negative, which are the yellow ones, and ran it over to the capacitor as well, ran them all together. Right now I'm not running off of this, I'm just collecting this to see how much voltage I can actually create here. Little disappointed. I was hoping for around 2400 RPM. It's running a lot less than that, around I can get it up to around 550 RPM if I take my charging coil back away from the magnets. I'm getting quite a bit of a cogging effect from the core of these. The core in my coils, soldering, or this is brazing rod, solid brazing rod, so there's quite a bit of a cogging effect there. One thing I did find, that if I run my run coils up too close, up within an 1/8 inch of the rotor, I found that it actually will just barely run at all, hardly turn at all. So I've had to actually move it back quite a distance, and I picked up a lot of RPM the further back I went, the higher the RPM was for me. Anyway, the way I'm powering this, I've got a small battery, which right now I'm not using back here. It's just a small battery like you take out of a riding lawnmower. What I'm doing, I'm actually using the power supply, and I'm running from the power supply into another capacitor. This is a 52 volt capacitor, and then from there I'm taking the positive and negatives off of my circuit boards and running over to a lead off of this. I was just afraid that if I didn't have a buffer between my circuit and the power supply, I'm not sure how that power supply would handle that, the feedback from the spikes going back into it. So I just kind of used the capacitor as a buffer, and I'm not even sure if that's good or if it's doing what I want it to do, but I just it's been working so far for me. So anyway, we'll go ahead and get going. Like I said, I'm a little disappointed in the RPM. I'm going to go ahead and get the power supply turned up, and I'm not sure that you can see this. It's 0 volts right now, and I'm just going to go ahead and turn this up about 15 volts just to get it going. Didn't like that. Like I say, since I put my since I put my charge coil on here, it's really giving me a lot of drag on it. I need to support my framework here. It's really slowing me down because it's not sturdy enough.